Sure, sorry.
Yeah, please go ahead. It's recording.
Hello, everyone. Welcome to today's series, right? And today we are planning to cover about add-on card modeling in the PLDM form, right? And how it has to be done from BMC point of it. I'm Richard. I work in both, all platform formats, including UFI and OpenBMC. Earlier, I have covered user management related session, and this will be related to PMC. So right now, actively working in PMC related specification implementations. That's a short intro about me. Okay. So related to the targeted audience, I just want to make sure that all audience is having some basic knowledge about what BMC means. Of course, everybody in OpenBMC community must know about it, but I just thought to cover that one. Similarly, satellite management controller. Many people will have a different word. Some people will have add-on card management controller. Some people, call it as a endpoint management controller or regular management controller. So there are many words for this one, but it is just like an add-on card. You are having a management controller which is used to manage your add-on or add-in card. That is what we are calling it as a satellite management controller in this whole specification. And regular add-on or add-in card, right? PCI slot. So whatever we are trying to cover will be generically applicable to expansion card. But as we say it as a modeling, many things is like a reference, and your modeling behavior will change based on your requirements or usage needs. And there should be a basic knowledge about PMCA, and I believe already Deepak has covered introduction to PLDM. So whoever needs some intro to PLDM, they can go ahead and look at the presentation. That will be helpful in order to understand this particular presentation too. Having said that one, let's move to the agenda. So first we want to start it with a platform with card and a high-level architectural overview. After that, we will go about a brief overview about card modeling, what we mean by card modeling and stuff, followed by how it is done before PLDM was in position, or a few years before, how it was that, right? And how the card modeling is projected from PLDM way, or how it has to be done, right? So that's one thing we will try to cover, followed by a quick recap on all the summary, and then with reference materials, when the PPT is distributed, you can have a look at the references. So this is a high level add-in card. The left side, you can call it as a motherboard. So generally all motherboard will have any host CPU or PCH, followed by a BMC. This is what we call it as our management subsystem or center of the management kind of stuff, right? Which will have, and ultimately each board will have multiple PCI slots. So management BMC can directly connect to the PCI slot through separate I2C bus, or you can have a MUX, whatever the design decisions, right? You can in that angle. But in our add-in card, ultimately, you're going to have a processing unit. It can be like an FPGA or any accelerator or GPU, DPU, IPU, you name it, multiple things are there, right? Ultimately, that is what the functionality is going to be, including NIC or whatever it is, offload unit, right? So then you can even have a satellite management controller, which will be connected to your baseboard management controller through I2C or SM bus. And we can also have some physical EEPROMs, some sensors, and some fans, and some more hardware devices generally in our add-in card. So these are all is in a high level representation, right? So few things what we have, I just want to highlight is that there are devices which is in standby power, and all those things which is connected to baseboard management controller. So if you are able to reach through this I2C SM bus to satellite management controller, this is called as an out of band channel. We will be able to access through this channel, and without host CPU power on, you will be able to reach or control or do whatever we want to achieve certain things from the add-in card management controller. So that is what we are calling it here. And as I said, all components doesn't need to be mandatorily present in add-in card based on your card. Sometimes there are certain cards which doesn't even have a satellite management controller. So what it means is probably your processing unit or your controller itself will have a embedded controller, or there will be a minor core which will take care about this function. And Either it can connect to BMC through I2C SM bus, or it can directly connect to through PCI itself, and will support only in-band channel. So all these are possible ways. So every combination or permutation combination we will not be able to cover, but as a part of our understanding here, what we are trying to do is, there will be some kind of satellite management controller or a hardware unit in order to achieve the modeling. So that is what we are trying to cover in this PPT as a whole. And there can be multiple sensors, multiple fans. Sometimes some fans will not be present. So all this is for representational purpose only. Moving on. As a part of card modeling, we need to do following things, right? This is not extensive list. I just made it just for higher level modeling only. But we can even add multiple things, like from security point of view, we can even add all those things are also is a part of card modeling. But in higher level, whenever we say inventory, the logic here is we need to identify what is the add-on card which is connected to the system. And we need to understand the model or whatever it is, and accordingly enroll it to the orchestration software or inventory data center management software, right? That is that inventory or FRU is what we are calling it as a card modeling. Then the next one is a sensor representation. When we say sensor, it is a combination, right, including your metrics and stuff. So I just want to cover it as a whole, not as a separate one. So sensor representation, a regular temperature sensor, you can have temperature, voltage, power, current, and then some metrics related to telemetry kind of stuff. And similarly, events, when something goes wrong, or some events, some counter is exceeding, we want to generate a event kind of stuff, right? So these are all is what we are trying to vision how it has to be done kind of stuff. And similarly, firmware update is another important stuff in add-on card. So and apart from that, another thing is the external communication interface. So our external communication protocol, right? Here I just call it as a Redfish, as PLDM is our way, and we need to represent it in a Redfish form. But yeah, sometime back, if you go back over history, we do certain external communication interface through IPMA itself, even for the add-on card. So that is also still possible. So before PLDM, right, card modeling was done in two forms. So in over a higher level, we call it as a direct hardware connection through I2C or SM bus, or as through IPMB protocol. It is still using the physical interface, will be like I2C or SM bus, but we will be using the IPMB protocol to communicate with the firmware in the add-on card, and we will be using IPMA commands in order to communicate it, right? So earlier to PLDM, there are two kinds of representation even for FRU. So for example, in an add-on card, we can have a physical EEPROM, serial EEPROM, which is there in our I2C bus, so that BMC can directly come and read the EEPROM using a regular I2C or SM bus command, right? And this will follow the standard IPMA FRU format. So IPMA FRU, is like in EEPROM itself, we can add and maintain it. So in this way, what happens is sometimes if there are some low-end cards kind of stuff, what people used to do is they will have only EEPROM, and they used to represent the card through this EEPROM itself. So just for inventory purpose alone, they used to do this one. Then another model is there can be a SMC, a controller, smaller controller, which will run some firmware. It can support IPMI FRU commands. So as a part of our IPMB protocol, what BMC can do is it can issue to the SMC using get IPMI FRU, get FRU commands, and it can try to read all the FRU details from the add-in card SMC firmware. In this way, BMC will be able to know the FRU details of the add-in card, and accordingly it can advertise the inventory kind of stuff, right? So this is also another possible way. Earlier, before PLDM, we used to follow. And then coming to sensors, even in add-in card, sensors are represented in two ways. One is there can be a sensor devices which is directly connected in the I2C bus. That is, BMC can come and directly read and access it. So generally in those products, what people used to do is in the product specification data sheet, they used to publish saying that you access this particular address offset, or register offset, and the first register offset probably will give you, temperature sensor, few other stuff. After few register, it will give you voltage sensor related details, all those things, they used to document. And in BMC, we need to hard code. It is like regular how in a platform we used to do the sensoring. What we need to do is based on fruit detection, we apply those principles like a sensor data record, we automatically load it, and the BMC can directly go and scan those hardware sensors and accordingly take certain actions. So this is one form of representation earlier we had. Then we also, earlier supported like something called as IPMI again. So it's the same thing, similar to how IPMI fruit, there will be an IPMI stack which is running in the SMC firmware. And what BMC can do is BMC can talk to SMC firmware through IPMP protocol, and it can ask, give me your STR details. And similarly, it can go ahead and corrigate sensor reading. And even eventing kind of stuff is also supported a little bit, but it is, not full-fledgedly used. Then related to the firmware update, IPMA as such does support firmware update, but unfortunately, many of these commands are like OEM, firmware update commands, right? And there is no standard way across different vendors. So this was one of the main problem related to the firmware update, right? And related to the external exposure, BMC can expose sensor details of the add-in card and through all those things to the data center, data center management software through either as a sensor or as a flow. And again, this is as a part of IPMI standard, right? But there are all, a lot of cons are, over the decade, industry is moving towards a lot of, models which can be emulated using IPMI as such. So like, let's say that if I have a direct I2C or SM bus, BMC must know about the device true, earlier before we add any card, right? So that what BMC can do is BMC will know that, okay, whatever the card connected is X card, and if X card is connected, the sensors are in this particular address location or register offset, and through that one it has to access. So we need BMC to be updated, or BMC must be aware about all those support. In case of IPMI, certain dynamic approach is there, but still it is not scalable, in terms of many features, right? And IPMI specification is now no longer supported. We are totally moving towards DMTF related specifications, right? So these are all certain cons which we had in our earlier PLDM model. So before going on to PLDM model, I just thought I'll have a quick few seconds to talk about the PMC architecture overview. So this should have been already been covered by Deepak. I'm just for refreshing purpose only, I'm just covering. So this is a management controller. It can be BMC or it can be multiple BMC in whatever way our chassis is designed, right? But assume here whatever we are going to talk about is BMC is this management controller, and the add-on card is what we are going to call it as a managed device, or if it is a card, probably your network controller can act like a managed device and it can communicate, right? And the communication towards BMC will be using, mostly using MSS SM bus and in-band channel mostly with PCIe. We can even also have RBT if that is not needed. But in this presentation, whatever we are talking is just excluding RBT, and we are directly talking about MCTP or SM bus or PCIe as in-band communication mechanism. And having said that one, the external remote management console is something our external facing protocols. So we are going to talk on in terms of Redfish alone. And right side is the PMC stack layer. So PLDM as such is what we are going to talk, and it will be PLDM over MCTP, and MCTP will further be either MCTP over PCA or MCTP over SM bus. And majority of our discussion is going to be like MCTP over SM bus is what we are talking about in terms of the add-on card. Okay. So now coming to card modeling in terms of PLDM. So PLDM for FRU DSP257 specification talks about how a FRU has to be modeled. So now this is totally different from IPMA FRU. So this is not in aligned with IPMA4 specification, right? So we are having a different way, but there are this provides certain entity associations related to the fru, and we can have multiple representation also. And one of the key points here we need to see is similar to, like IPMA fru, this doesn't support or talks about how we can maintain the PLDM fru directly over EEPROM kind of stuff, right? So it's like a firmware level PLDM fru representational only, and the choice is also, in one way it is right, right, because we are having too many instance and association related stuff, so we need to represent that also. And from firmware itself, if we are able to read it, there is no point in having another extra EEPROM and maintaining it. So PLDM for fru support in the tangle. So this is one way where we can emulate any add-in card. So once we connect, BMC is talking to add-in card. Through PLDM based specification, it will try to learn like what are the PLDM types it is supported, and if the add-in card says that it supports PLDM fru type, BMC can go ahead and read all the fru tables, and accordingly, understand like what is this inventory, and it can expose those information as and when required. Now, related to the sensors, I just mentioned is a sensor in the highlight, but it is having sensors, effectors, whatever we want to have, right? And all those things are covered as a part of PLDM for platform monitoring and control specification 248. And what here is, there are again certain commands similar to how we earlier had IPMI, right? Like get sensor reading kind of stuff. It is also having this one. And similar to how IPMI maintained sensor data record, here we are having PDR. So using PDR, we'll be able to understand, or it's like a metadata for the sensors effector. So it will explain what is the sensor type is about, or what is this effector type is about, and how this sensor or effector is associated to the add-in card. Is there is any entity related associations, or it is contained under a single stuff. Everything will be able to provide it using this PDR. So for example, if we have a controller, and if there is a temperature sensor inside that controller, then using the entity association, we will be able to say that there is a temperature sensor, but this temperature sensor is inside the controller, whereas there is an ambient or inlet temperature sensor which is outside the controller, and this is a part of add-in card system. So those kind of stuff is still possible, and platform monitoring and control specifications covers all those things. Similarly, platform monitoring and control, it's talking about eventing stuff. So BMC as a PLDM subsystem manager, what it can do is once it detected add-on card, it can go and configure the event receiver indication, so that when there is an event happening, add-on card can send a message to BMC, and BMC will know that this particular add-on card is having some problem, or whatever event has happened, it will be able to monitor it. So this is another way of sensor monitoring, right? So either BMC can go ahead and query the sensor as per the interval whatever is been advertised, or it can even monitor the event if the add-on card supports eventing also. So these are all certain possible methodology how sensors can be represented in through PLDM. Now, related to the firmware update, again, DSP267 covers this one. And a good thing about this firmware update is it will be like a standard way across different vendor, right? So when we say standard across different vendor means irrespective of the add-in card and irrespective of the BMC, the update, there is ability for BMC to discover the firmware device, whatever is needs to update, and to transfer the image to the add-in card or the firmware device, and then getting it updated and activated. Everything is defined in a standard form. So this is one of the difference when we compare with the earlier versions of all our representation. This gives a bigger advantage for us right now, either from host end or from BMC end, irrespective of vendors. All these things are going to be in a common form. Now, many add-in card already started supporting this one, so that's one of the good approach, right? And next thing required in terms of the modeling is external exposure. So when I say here external exposure is external communications or interfaces, right? So how an add-in card is exposed to a data center manager software. or a orchestration software, or in terms of a user level a Redfish client kind of stuff, right? So again, here is also some possible ways are there. So one is BMC emulates the device based on the MNC, that is PLDM monitoring and control specifications PDR data. So what it can know is, okay, if it knows there are 4 sensors, like say 2 temperature and 2 voltage sensor, then it accordingly expose that information. Or else there can be another way is also, which PLDM again covers in a different specification. We call it as PLDM Redfish device enablement. So through this mechanism, Redfish as such can be owned and represented by the device itself. So we'll cover this two a little bit in detail. Okay. So the first one is the sectional Redfish exposure in terms of BMC emulation, right? So the reason why we call it as a BMC emulation is it again depends on how BMC can emulate the possible ways, right? So again, this is just for reference only, and it does not mean that this is a proper way or improper way, right? Based on requirement and your usage needs, certain representations has to be will be different. Okay, so please exercise caution when following this one. So here what we are trying to see is, let's say that there is no RD support in add-in card or add-on card. Now BMC tries to query, and the add-on card supports PLDM fru or PLDM monitoring and control, all those things, right? Now all these things has to be exposed to the through Redfish, right? And as part of DMTF, yeah, Redfish is our primary interface level external communication interface. So there are two options here again. One is you represent the add-on card as a separate chassis itself. So we can emulate, there is a whole chassis, and inside that one, the container, add-on card itself can be accessed as contained by the external chassis kind of stuff. And through this one, the advantage is, we can emulate all sensors, including power, thermal, and metrics through, whatever we want, we'll be able to emulate it. And we can even combine with RDE2 according as per the link, whatever it is required, right? If the parent is there is there is a minor catch there, it doesn't needs to be conflicted with the parent flows. And another option is we don't need to represent it as a separate chassis as such, and this option works better when the card is very simple. Like let's say that it's a normal add-on card with say 2 temperature and 1 voltage sensor, or 2 voltage sensors, or few fan sensors is what it's ultimately is going to have. Then what we can do is instead of representing it as a different chassis, we can represent the same sensors in the thermal and power schema, and using the related item property, we can point it to the particular PCI device such that it will be able to represent how the entity is associated, or this particular sensor is associated to the particular PCI slot or PCI device kind of stuff, right? It should be PCI slot, I believe. Sorry for the correction. So, and the second stuff is Redfish exposure through RDE. In this one, the BMC will act like a proxy. Basically, it is a translator proxy. So what RDE expects is BMC to act like an intermediator, and BMC has to translate a HTTPS or JSON request, whatever is coming from Redfish, and convert into a binary encoded JSON, right? And send the binary encoded JSON to RDE device. So the reason for this conversion is, majority of the time, the communication channel between the management controller and the RDE device will be like SM bus or low bandwidth devices. So it is not wise to transfer the JSON kind of stuff, right? And that's the reason it has been decided in that way, is what I believe. And based on that one, now management controller will do the conversion, send it to an RDE device, and when there is a response is received, it will again convert BEJ to a regular JSON, and it will send back to the clients. So this specification even talks about how the Redfish schema, URI, everything has to be exposed. So for example, any RDE device can expose certain schema differences which is not available in BMC, right? Or it can expose an extra schema and anything whatever it is needed, including a OEM kind of stuff, right? The only thing is the management controller. There is the specification talks about how it has to download the schema dictionary, how the decoding has to happen, everything. So as long as those things are properly implemented, then whatever is the RDE device, that is add-on card firmware, want to emulate it as a part of user level interface can be done by the BMC. So a BMC doesn't need to take any extra action how it has to be represented. The representational flow can be fixed by RDE device itself, saying that this is what the schema has to look like, or this is the actions which needs to be taken in that particular property or schema. And that can be accordingly exposed, and a client, Redfish client, can make use of this approach. So this is one sample stuff, right? And a link is provided in order to do very deep dive if you want. And there is also a material which talks about Redfish RD deep dive, a DMTF material. I have added the reference to that in our reference slide also. So basically, in this angle, like let's say that Redfish wants to query certain things, so it'll tell that query to the management controller. In this case, it is BMC. Now, what BMC will do is BMC will initiate the operational init to the RD device, and based on that binary encoded JSON data, it will be encoded, and it will go and perform that action, and based on that, it will send a success message. Then BMC can come and requery the data, and once it receives the data, it will forward that message or the success message back to the Redfish client. So this is just for a simple read operation, right? Similarly, we have write and HTTP all HTTPS method, right? So everything is in detail in the specification, but here what I want to introduce is, so there are two ways to tell, right? One, BMC can emulate certain things. Another thing is BMC acting like a proxy, such that the device, whatever the add-in card or whatever the device itself is, can tell, saying that how the Redfish interfaces, whatever it is required, has to be emulated. And there is no hard and fast rule saying that which spec has to be followed, or whether only RD is a way to represent it. The reason is because anyway, MNC is needed. That is monitoring and control in terms of regular sensor monitoring and taking certain action based on an add-on card. Like let's say that when we have an add-on card, we may need to do a certain thermal management as a part of the add-on card's temperature, right? So sometimes if the temperature of the card is too high, probably we may need to spin our board fan speed also. So in that way, anyway, BMC has to go and read certain temperature sensors in the add-on card, and it has to represent. So as I said, it again depends on certain requirements and stuff. But from standard point of it, it has been stated saying that, based on your requirement, you can have your RDE devices emulated. And if you don't want any sensors separately to be emulated, yeah, we have to just get it removed from PDR kind of stuff. Else, we can have a combination such that certain OEM related actions or certain schemas alone can be exposed by RD devices, and the sensors or all those things we can let BMC to manage and expose it accordingly. So both are possible ways. Oops. Okay. This is one form of RD example, right? Here, my intention is just to give an highlight, right? Like how the PDR, which talks about, tells so that BMC can go ahead and construct the particular chassis. Now, whenever we query, it is actually the add-on card which is responding. It is not the BMC, right? So for example, BMC will come and read the PDR representational. Here it will tell that the major schema name, whatever we support, is storage, and ultimately it is part of drive schema. And there are multiple resources, like 4 resources stuff, and all supports sanitizers and action name, right, in that schema. Now, apart from that, they are also having some entity associations, how it has to be associated with external chassis resource. It specifies that also. But now what BMC, from BMC point of view, it has to do is, it has to know that the parent URI is the storage collection, right? So according it will do. And further below this one will be taken care by the client, that is the device subject itself. So when there is a request which is targeted for this URI, BMC will just convert that as a binary encoded JSON, and it will forward to the endpoint device, and endpoint device will be able to respond towards this one. So this is in the high level representation. And now moving on, right, the same NIC modeling. So network controller. So the entity association is a way which we normally do. So this is just for an example, right? When we model how the PDR is going to be used, such that BMC has to read this PDR and entity association, and accordingly correlate or put the related item in its corresponding grouping. So it will know that this network temperature, this network controller temperature is under the container of network controller. So if you see here, we are calling it as a network controller temperature sensor, and the container ID is pointing towards 144, and that is nothing but a network controller. So what basically indicates is this temperature sensor is contained under the network controller. So network controller is a container, and this container is containing this network controller temperature sensor. Following by that one, it can even have more stuff also, but that is what we are representing. But when we take the NIC temperature sensor, here we are representing, saying that this is a part of add-in card itself. That is the container ID is nothing but our system. So here we are representing, saying that this is a part of system and not binded to any network controller as such. So this is how the modeling will be done, and it will relate that how each and every sensor is related to which part of the card or which part of the controller when there is a multiple controller. And through this mechanism, we will be able to identify which part of the card's component is having a trouble, or we will be able to measure the metrics accordingly. Like let's say that even if we want to collect some metrics from here, it will be represented, and it will represent saying that, okay, this is part of network controller 1 power, and probably if you are able to measure network controller 2 power, we will be able to accordingly tell that one. And based on that one, orchestration software can decide saying that, okay, this is taking more load or less load, and accordingly it can take action, right? And similarly, if I have a common aggregated network NIC power sensor which is outside this one, through that one we will know how much power this whole add-on card is consuming, and accordingly the whole platform power can be managed in an effective manner. Now, this is again from PLDM NIC modeling white paper, but it talks about the enumeration schemes, right? So these are all is like samples. So wherever you see this max count, it's something like you are having like one NIC card as such. That is, this is one add-on card is what we are trying to represent, and the container ID of this one is starting with 100, right? So 100 is what the container ID we are maintaining. And the second one, container ID, is the maximum level of container ID. What it means is, like, let's say that in this card, the enumeration scheme, whatever it is explained in the specification, is talking about saying that there can be 20 connectors. If you want, you can have, like, let's say that if you want to limit with 10 connectors, that is also possible, but you will be just limiting your container ID from 1040 to 1050, sorry, 49. So accordingly we can change, but this is just an emulation, right? But this is now a enumeration scheme from maximum count point of view. If you want to have exceed this one, it is still possible, but only thing is accordingly you need to change the container ID and your handle base, everything, and then it will still work. But this enumeration scheme talks about in that angle. So as I said, we are having a regular NIC temperature sensor. This is from system level point of it, and we also have temperature sensors per network controller, and there are 10 entries, right? Now all these entries, will be able to point it towards this one, right? Network controller in the entity association kind of stuff. So in summary, what I want to take away is like now industry is moving towards PLDM, right? And both BMC point of it and add-on card or a device point of it. Many products are now PLDM compliant, and everything is coming as a PLDM compliant. And if we need a backward compatibility, either in terms of BMC or in terms of device, then we may need, we have to end up in supporting multiple protocol. Like let's say that if we want our OpenBMC to support a certain add-on card, which may be like IPMI only compliant or which is not aware about PLDM, then accordingly we need to take care. But when we do multiple protocol support in BMC, we have to make sure that there is a correlation to differentiate, saying that the IPMA through whatever we read from EEPROM is also the same thing what we are reading it from PLDM as a flow, because sometimes device can end up supporting multiple stuff, and we have to be careful in identifying the duplication and accordingly work with one single protocol when BMC is also supporting multiple protocol and device is also supporting multiple protocol. So that is one of the things we have to take care. But as such, today in OpenBMC, if you take, we do support reading of EEPROM in IPMA flow format and handle that one. So that is already there, and we'll try to expose in our flow device EEPROM kind of stuff, flow device service daemon. But apart from that, we don't actually do a lot in terms of the add-on card, right? At least in OpenBMC, we have not yet went up to that level. Now we are directly going towards the PLDM logic. So many of the PLDM related work is started in OpenBMC, and it is already in progress. So we are trying to align everything towards the community and coming to a single common repo, right? Like if you take through sensor and firmware update are already work in progress in terms of OpenBMC. Eventing, it is still not yet started. Similarly, external interface, that is RDE spec, that is also not yet started in OpenBMC, but probably in future we will start that one once these are all aligned and we enabled many people in this angle, right? And like let's say that through both as a responder and a requester flow is also there. So all those things is we are trying to cover. And today in current market, products are available in combination. So the reason why I just want to highlight is I just want to say that even though industry is moving towards PLDM, today all the devices, we cannot assume that all devices as of today is in PLDM, right? It is going to come probably in a year. Everything will be a PLDM supportable device is what may come out. But till such time, there is going to be a combination. Now, if we take an accelerator card, Xilinx by Xilinx, the way it represents through in an IPMI flow format, that is a physical EEPROM kind of stuff. Whereas all the sensors are represented as a part of PLDM. So it does support PLDM base specification and PLDM monitoring and control to give out all the temperature, voltage, and power related sensors. But it doesn't support PLDM through specification. So now this is an example of combinations of support, right? Probably, if EEPROM is what is only supported, they want to just advertise saying that through this EEPROM through a BMC which doesn't know PLDM protocol will be able to identify that this is an Alio card if needed, and accordingly take or load some other sensors kind of stuff, right? So that is probably the reason they might have designed like this. But I just here the intention is to give an example saying the combination of protocol is still possible, right? And this is what in a high level how we can be represented. Like let's say, a recap is if there is a through EEPROM you can support it, either it is an physical or emulated EEPROM. Then through IPMB protocol, there is IPMI as a part of I2C or I2C. Still, we can support flu, and PLDM flu specification is also available. Similarly, for sensor, it is there. Only difference is certain things cannot be done through direct I2C or SMS on such things as events. Today, we don't cover that one in a standard form, or there is no direct mechanism, right? There can be some proprietary mechanism, but not in a standard way. Similarly, firmware update, mostly it's not needed in case of direct as I2C or SMS. There is nothing to be updatable there. But in case of IPMI, many things are in OEM format only, so we don't have a standard way to upgrade it, and that's where the PLDM is having advantage, right? And apart from that, PLDM is having the multiple types or multi instances. So add-in card can have a combination of multiple subcomponents, and PLDM will be able to represent that subcomponents and its entity associations in a better way when compared with IPMI kind of stuff, right? And it also support like multiple, when we have multiple component images, we'll be able to update a single component as such as a different form. So this brings wide variety of manageability in an easier form, right? So that is some advantages of PLDM. So having said that one, these are all certain reference links, and we are also having OpenBMC PMC our group meeting. Unfortunately, currently it is in BDC friendly time, but I hope by next year, that is after New Year, we will try to start one US friendly time to align with many people in US or US time zones. But feel free to drop us a mail or send us a mail, and we'll try to cover. If there is any questions or in terms of implementation or any recommendations, let us know. We'll be able to see what best we can do there. That's it from my end. I'm open for questions.
Thank you, Richard. And are you on the Discord? Is PMCA channel?
Yeah, we just joined, but I'm not yet active due to internal pulled up. But yeah, after this vacation, I'll be back in active. Yes, Discord is. Yeah, Discord.
Right. I see some channels like say MCTP, and then do you plan to have anything like a PLDM? It looks like there is a lot of activity on the PLDM itself.
Yes. So Andrew, he's from Australia, right? So sometimes he maintains a Discord. So that's the reason the MCTP channel was started, but we'll try to convert that as a PMCA as such.
Okay.
So the work group, whatever we are running is PMCA. We don't want to talk only about MCTP as such alone. So MCTP, PLDM, or whatever is in the PMCA specification, including SPDM, we want to get it discussed there from OpenBMC implementational point of it.
Great. And also, like, is there any card, off the shelf that supports PLDM firmware update?
I believe so, but I don't have a link. I need to check and get back to you.
Yeah, that'd be good actually, just to kind of experiment with that.
But there are a lot of upcoming cards which will be able to support. Unfortunately, I cannot build that one. That's the reason.
Sure, I think
from Google point of view, I'll check.
Yeah, I think I know like NIC cards, they are supporting this, but they are on the PLDM over NCSI, the RBT. So
the good thing is, or at least one of the thing what I forgot to mention is PLDM over MCTP or RBT. The upper layer application doesn't need to change a lot. So in OpenBMC, at least whatever we are designing, we are trying to make sure that this will be like bifurcated correctly, right? So today PLDM is a separate daemon, which forward its packet to MCTP. But today, whatever the design we are doing is we can have multiple MCTP instances. When I say multiple MCTP instances here is from software point of it, not from spec or the architectural point of it, right? So each and every binding we are planning to run as a separate instance, so that if you are not supporting bridge, we thought that this will be faster, as one slower interface is not going to stall our other high-speed interface. So we are running some multiple instances, right? So PLDM today, we will be able to talk to multiple PLDM, MCTP instances, and RBT we can consider it as another instance, and it will still be able to support. So the integration of PLDM to RBT is also not like very differentiable one, but the only catch is the TAD to EAD assignment, right? So today, when it comes to MCTP, it is TAD to EAD we are converting, and that kind of conversion requires a certain code change. So it will be like minimal, not like rewriting a whole PLDM stack, but there is a little bit of change which we may need to do in terms of this one. Once that is done, then from upper layer point of it, whatever, like let's say that the PLDM specification, whatever we are trying to support, will not have any problem at all. Only in this transport and binding physical layer is what we need to make certain changes.
Great. Yeah. So can you talk about anything that is upcoming in the next 6 months or 1 year into the OpenBMC?
Okay. So currently we are in active development of FRU sensors and firmware update. So this is what we are targeting. And actually speaking, even though we are having the OpenBMC PMCA work group from in which both IBM and Intel discuss it. Today, the community code, that is whatever is in community OpenBMC, SI, MCTP, and PLDM stack is a little bit different when compared with Intel BMC, right? It's not like our intention is not to deviate, but what happened is the usage case was different. In terms of community or IBM point of it, majority of the stuff is like a responder flow. Like PLDM through responder is what BMC is acting like. So host can come and ask, and PLDM, BMC has to respond to it. So or it is like a peer-to-peer connection in terms of implementation, right? Whereas our requirement a little bit, in a different manner. So we didn't took the socket approach. And we decided that that is going to put a stall in our schedule. So what we thought is we'll start ahead with this one, but we are having a wrapper layer such that whether it is socket or a dbus, there won't be any. We want to hide it from the upper application, from PLDM application, right? So PLDM application doesn't need to worry about how the communication has to happen with MCTP daemon, whether it is socket or dbus for transmitting a packet. But unfortunately, when from our MCTP stack, when there is an add-on card connected, we want the PLDM stack to know, saying that there is a new device has been found. And it is, even though it supports multiple MCTP types, it has to indicate saying that it supports PLDM message type, so that the PLDM daemon can go ahead and further query as per the PLDM case specification. So from which it will learn saying that, okay, this particular, there is a new card connected. It is got a new MCTP endpoint ID, and it is having PLDM message type supported, right? Then PLDM daemon will go ahead and query in terms of PLDM message type subtypes. Then it will know that, okay, it is supporting flu, it is supporting MNC, and it will further query that one and accordingly construct everything. So for this purpose, there is a deviation, but our plan is actually earlier plan was by Q4 we will be starting and converging all our code to single stuff, but there was minor delay. So right now we are planning towards Q1 end is current our target is. So that is where we are in.
Great.
So
Cool. Any other questions from others? Or they would like to thank Richard, taking this late night session for us.
sure. No problem, sorry.
Yeah, thanks a lot. I think yeah, this concludes our learning series for this year.
Yep.
Thank you all.
Yeah.
You started and ended it. Thank you.
Yeah, that's true. Okay. Yeah,
Great.
thanks everyone, and feel free to shoot an email if you have any questions. That will be beneficial, right? I have a habit, like when there is a question, I'll try to cover that in the slide itself. So I'll capture Sai's question and try to cover that one and upload the slides to Sai. So let me know if there is any question. We'll try to cover it in the slide also.
Great. Thank you all. Happy holidays.
Thanks everyone. Happy holidays. Bye.